So what we are focusing on now is we are going to focus on addition and subtraction of rationals. And rationals are fractions on steroids. We're going to start having variables in the denominator. So we're going to look into this. Now, this problem right here is one that we talked about at the beginning of the semester, and we have to find a common denominator. So our LCD for this, we have 3/5 plus 1/6 minus 13 over 15. So our LCD, what's our LCD going to be for that? 30. Okay, so 30 is our LCD. Okay, so what I do is I rewrite each one of these with a denominator of 30. Okay? Then I say 5 times what gives me 30? 6. Good. So then I multiply the numerator by 6. So I have 18 over 30. Then I say 6 times what gives me 30? 5. Good. So I multiply my numerator by 5. And I have 5 over 30. Then I ask 15 times what gives me 30? 2. So I multiply my numerator times 2. Okay? And I have 18 over 30 plus 5 over 30 minus 26 over 30. 18 and 5 gives me 23 over 30. Negative 26 over 30. So my final answer here is negative 3 over 30. I said final answer, but that's not my final answer. Why? Good. It simplifies. And I can simplify that to negative 1 over 10 because 3 goes into both of those. Now, this is how you've been doing fractions, and it's completely fine. But because we are moving into rationals, I want you to think about it differently. Okay? So, do you remember how on Monday I talked to you about doing the prime factorization of numbers, breaking a number down completely to primes? That is what we are going to do with these denominators. So instead of we are going to say 3 over 5 because 5 is prime. Okay? 5 is already prime, so I can't break it down anymore. 6 can be broken down. What can 6 be broken down to? 2 and 3. Okay? 15 can also be broken down. What does it break down to? 3 and 5. Good. So what we are going to do for our LCD is we are going to make sure every single number here is covered. So I'm going to go ahead and write down this 5 as part of my LCD. Okay? And that's covered. I've got it covered in my LCD. Now, are either one of these numbers already written down? Okay, so up here in my red for LCD. Have I written down a 2 or a 3 yet? No, so I'm going to go ahead and do that. So I'm going to have 5 times 2 times 3. Okay, so I've got this 2 and I've got this 3 covered. Is there already a 3 written down for my LCD? Yes. Is there already a 5 written down? Yes. So I have it covered. I don't need to write down those again because I've already got them covered. So what I want us to do now is I want us to look at this using our primes. So I have 3/5 written. Here, my 5 is already covered. What's missing? What's missing? From my LCD in my 3 over 5, I've got the 5 covered, so what's missing in my denominator? The 2 and the 3. So I am going to write down 2 times 3 in my denominator. But if I put it in my denominator, I also have to put it in my numerator. Okay? So now I'm going to go to the next one. So for this one, I already have a 2 and I already have a 3. But what am I missing? I'm missing the 5. So I've got to write down the 5. And I have to write it in the numerator and the denominator. Now, I'm going to go ahead and write this as plus negative 13. I have a 3 and I have a 5 in my denominator. What am I missing? The 2. So I'm going to write down the 2. Okay? Now we have essentially done exactly the same thing. We've thought about it a different way. Thinking about it a different way helps us solve the more complex problems. Okay? So now I have a denominator of 30 because 5 times 2 times 3 is 30. And then I have 3 times 2 times 3, which is 18. 1 times 5 is 5. Negative 13 times 2 is negative 26. When I simplify that, I get negative 3 over 30. And I know I can simplify that again to negative 1 over 10. And that is my final answer, negative 1 over 10. Okay? So, now let's add some variables. Are we ready to add some variables? Okay, here we go. I have a minus 2 over 2 minus a minus 6 over 6. Now remember on Monday I said you cancel all of the binomial or you cancel none of the binomial. So this 6 and 6, can they be canceled? Or this 2 and 2? No, they cannot be canceled. You cancel all of it or you cancel none of it. That's how that works. All of it or none of it. Okay? So I'm going to go ahead and I'm going to break down my denominators into my primes. So I have a minus 2 over 2 because 2 is prime. I can't do anything with that. Okay? Now I want you to remember that that a minus 2 is a binomial and it has to stick together. Then I have minus a minus 6. And I'm going to go ahead and put that in parentheses. I can break my 6 down to 2 times 3. So, when I am trying to find out my LCD, I write this 2 down first. I do not have to write that 2 down again because I've already accounted for a 2. But I do need to write down the 3. Okay? I also want to go ahead and deal with this negative sign. I'm going to make this plus a negative in my numerator. Students often make a mistake right there with that negative 1 because that negative 1 has to be distributed across the numerator. So that negative 1 goes to the a and it goes to the negative 6. Okay, so now I have a minus 2 over 2. What am I missing from my LCD? 3. So I've got to multiply my denominator by 3 and my numerator. What am I going to have to do with that 3 in the numerator? Yes, good job. Then I have plus negative 1 plus negative 1 times a minus 6. Am I missing anything in the numerator here? No. A common mistake, though, that students make is they forget to distribute that negative. It's a very common mistake. Okay, so now I've got a denominator of 6. I have a denominator of 6. I'm going to do 3 times a and 3 times negative 2. So I have 3a minus 6. Then I've got to distribute this negative. So then I have negative a plus 6. Okay. 3a and negative a leave me with 2a. What's negative 6 and positive 6? Good. Okay, can I simplify that again? 2 and 6.
1 over 3.
Okay, and don't forget your a. So a over 3 or 1a over 3. Okay, now our next problem really shows why it is so important to break down your denominator. Okay, it shows why it's so important. Can I go to the next screen? Good. Okay. 3 over 2x plus 5 over 3y. Okay, here's my LCD. I'm going to go ahead and write down my 2 and my x. So I have 2 times x. My next denominator, I say, do I have a 3 already there? Do I already have a 3? Okay, do I already have a y? Okay, so my denominator is 2 times 3 times x times y. That's my denominator. So I have 3 over 2x. What's missing? Good, a 3 and a y. Okay, this is why you've got to write those out. Students almost always identify the common denominator as the 6. They do not always recognize the x and y as part of the common or least common denominator. So writing it out is helpful. Very helpful. Okay, so now let's do our second rational. So I have 5 over 3y. What am I missing in my denominator? 2 and x. Good. So I write it in the denominator and I do it in the numerator. Okay. So my denominator is 2x times 3y. So that is 6xy. Okay. 3 times 3 times y is 9y. 5 times 2 times x is 10x. Okay. My numerator is a binomial. I cancel all of the binomial or none of the binomial. I can't cancel parts of it. So there is nothing that I can cancel here. Okay, is it okay if I go to the next screen? I see 1 or 2 people writing, so I'm just going to pause. Okay. Okay. So now I have 7 over 12ab minus 11 over 15a squared. 7 over 12ab minus 11 over 15a squared. Okay. I'm going to go ahead and break down both denominators, and it's easier to see if we break these down. So I have 7 over 12. To break down 12 into primes, it's 2 times 2, which is 4, times 3. Then I am going to write out the a times the b. I'm going to take that minus, and I'm going to put it in the numerator. Okay, 15 breaks down to 3 times 5. Then I have a times a. So for my least common denominator, I've got to have 2 a's in it. A times a. I've got to have at least a squared. So my LCD, I have a 2, a 2, and a 3. And then I have the a times the b. Okay. Do I already have a 3? So I don't need to write that down again. Do I already have a 5? No, so I need to write down the 5. Do I already have an a? Yes, So I'm good with that A. Do I have a second A? No. So I have to write down that second A. So I'm going to have 2 times 2 times 3 times 5. A times B. Now, eventually, we'll multiply all that out, but we're not there yet. We're not ready to multiply it all out. The reason is it's easier to find out what I'm missing when it's broken down. So I have 7 over 2 times 2 times 3 times A times B. So I've got a 2, I've got a 2, I've got a 3, I've got an A, and I've got a B. What am I missing? An A and a 5. And if I put it on the denominator, I also have to put it on the numerator. Okay? For this one, I have 3 times 5 times A times A. Okay? So I have accounted for a 3 and a 5, an A and an A. What am I missing?
2 2's and a B.
Good. 2 2's and a B. Excellent. Okay. Now I can multiply everything out in the denominator. So I have 2 times 2, which is 4, times 3, which is 12. What's 12 times 5? Good. Then I have A to the second power times B. So that's my common denominator. It is easier to figure out what you've got to put into your common denominator when you have it all written out. So I wouldn't multiply until the very end. Okay? 7 times 5 times A is 35A. Negative 11 times 2 is negative 22. Times 2 again is negative 44. Okay. Now, 35A minus 44B is a binomial. So I cancel all of it or none of it. Okay? Can I go to the next screen? Okay. X over x minus 3 plus 4 over x. Okay. I can't break any of my common denominators down. Can't break it down. What I want you to remember is that x minus 3 is a binomial. It has to stick together. You have to keep it together as a unit. So this x and this x are not the same thing. Okay? They're not the same thing. So my LCD is going to be x minus 3 times x, because I've got to account for this factor and for this, and you need to understand that they are different. X minus 3 and x are not the same. So for my first fraction, I have x minus 3. What's missing? Good. So I'm going to have x in the bottom and x in the top. For my second fraction, I have 4 over x. What's missing in the bottom? Excellent. Okay? So my denominator is x times x minus 3. My numerator is x times x, which is x squared. 4 times x is 4x. 4 times negative 3 is negative 12. Now, it is fine to leave it like that. That is a reasonable way to leave it. Or you can factor that numerator. That numerator factors to x plus 6 and x minus 2. So either one of those is fine. Okay, can I go to the next screen? Okay, 2x over x plus 1 minus 3. What is that 3 over? Good. It's 3 over 1. Okay, so I have 2x over x plus 1. And I'm going to write this as plus negative 3 over 1. My LCD is x plus 1 times what? What's in the negative 3 denominator? 1. So I don't have to write that. That times 1 just stays. Now, am I missing anything in my first rational, the 2x over x plus 1? Am I missing anything? No. My negative 3 over 1 is missing my x plus 1. So if I put that in the denominator, I also have to put it in the numerator. And it stays as a unit. So this is a common mistake. You've got to distribute that negative 3, and sometimes students forget that. Okay, so now I have x plus 1 as my denominator. So I have 2x minus 3x minus 3. What's 2x minus 3x? Negative x minus 3 over x plus 1. Okay, and that is our final answer right there. Okay, these take practice. They really do take practice, okay? And writing them